Hey guys, what's going on? Nice job today in class, really battling with and dealing with limit definitions of a derivative. They are algebraically tough, but the good news is there's a nice rule for performing derivatives to be a lot easier. So let's take a look at that. It's called the power rule of derivatives. I just want to start with a couple of things really quick. What if we, hopefully you saw this on problem 3. I asked you to find the derivative of 9x minus 2, right? And you got f prime of x equals 9. So let's start with something linear. So think about the graph of 4x. Y equals 4x would be a line with a slope of 4 and a y-intercept of 0. If I asked you to find f prime of x, right? Again, f prime gives the slope of the tangent line, or another way to think about it is the instantaneous slope. Well, the slope doesn't depend on x. The slope everywhere is 4. So f prime of x here would equal 4. So our rule is, if we have a function f of x with a constant times x, I'm letting c be a constant. So if f of x equals cx, I know f prime of x will always equal c. So that's one of the things that, right, anytime we have something linear, right, the derivative of 5x would be 5. The derivative of 20x would be 20. The derivative of x would be what? What if I said f of x equals x? What would f prime of x be? Well, again, think about that. That's just a linear graph with a slope of 1x, right? A slope of 1. So our derivative, if f of x equals x, f prime of x would equal 1. So this is derivatives of linear. So these are linear. How about a constant? What if I told you f of x equals 5? Well, if you graph that, if you graph y equals 5, what you're going to get is a horizontal line at 5. Well, what would the slope be of that horizontal line? Well, that slope would always be 0. So f prime of x would equal 0. What if g of x was -2? What would g prime of x be? Well, once again, this is a horizontal line. So the slope of a horizontal line would always be 0. G prime of x equals 0. So our rule is, if f of x equals some constant c, the derivative of a constant is always 0. F prime of x would equal 0. All right, now for the power rule. All right, so this is, horizontal lines. Okay, here's the big piece. What about polynomials? Okay, we know linear, we know constants. What about polynomials? Okay. Well, you may have seen this problem, or seen this pattern. So this is called the power rule. Okay. Let's think back to this one from the homework. Doing the limit definition, you should have found f prime of x to equal 3x squared. Well, the trick is, what we do is we take our power and we multiply it out front. Now, there wasn't a coefficient written there, but the coefficient is really 1. So 1 times 3 makes 3. So we multiply the power out front, and then we have to reduce the power by 1. We multiply the power out front and then dropped the power by 1, and that gave us 3x squared. So if I told you g of x equals 4x to the 5th, what do we think about g prime of x? We'll take that power, multiply it out front, and we get 5 times 4, which is 20. And it's going to be x to what new power? Well, I have to drop the power by 1, so it's 20x to the 4. Let's write the power rule like this. If my function is a polynomial that follows 8x to the n power, what would f prime of x be in terms of ax and n? Well, I'm going to take that n and multiply it out front. So I'm going to have a times n out front. And then I'm multiplying that by x. But I need to adjust the power of x. I need to reduce it by 1. So my new power is n minus 1. Okay, this is the power rule. Now, if our function has a polynomial with multiple terms in there, right, as long as they're connected with addition and subtraction, you can just keep applying the power rule to each piece. For example, let's say we have this. So, f of x is 7x cubed minus 2x squared plus 4x minus 5. My question is, what is f prime of x? Well, since all these terms are strung together with pluses and minuses, I'm just going to do the power rule on each one. So 7x cubed, its derivative would be 3 times 7, which is 21. So it's going to be 21x. Don't forget about adjusting the power. The new power, I have to subtract 1 from 3. That gives me 2. Okay. 21x squared. A lot of students forget to write the new power in there. Don't forget that. Then I'm going to multiply 2 by negative 2 and get negative 4. So it'll be minus 4x to the first power. But I don't need to write to the first power, because just leaving it blank implies to the first power. Now, what about this plus 4x? We know anything linear. The derivative of 4x is 4. The derivative of 10x is 10. Okay, so the derivative of 4x here is just plus 4. And the derivative of a constant is always equal to 0. So the derivative of negative 5 is 0, so I just don't need to write, I don't have to write minus 0 or plus 0. I just don't write anything else. There's my derivative. Okay. Now, question 5 on the homework was this. You're going to say, well, I can't use the power rule here. Well, you'd be wrong. You can use the power rule here. You just have to put it in ax to the n form, our general form. The square root means what power? Well, you should hopefully know from Algebra 2 and Pre-Calc that a square root is really to the half power. So I'm going to rewrite f of x. Before I calculate my derivative, I need to be in ax to the n form. So there's those are equivalent statements. Now, since it's an ax to the n form, a being 1, n being 1/2, now I can execute my power rule. F prime of x then would be, well, I multiply the 1/2 up front. 1/2 times 1 is 1/2. X. And my new power is to the net. I have to subtract 1. 1/2 minus 1 is negative 1/2. Now I can rewrite this. I don't like writing answers with negative exponents when I can change it to a positive. We know the rule from, Principles of Math. Anytime we have a negative exponent, we can throw it down into the denominator and call it a positive exponent. Well, I already have 2 down in the denominator, so it looks like this. These are equivalent. I also know that half power means square root, so I can write it ultimately like this. And if you solve number 5 on your homework correctly, this is what you ended up with, 1/2 root x. Okay, the reason I want to change it, all 3 of those answers down here, all 3 of these are exactly the same. But I want you to get used to putting it in this form, because when I ask you f prime of 4 without a calculator, it's much easier to solve it in this form than it is in either of the other 2. Okay. Last example for today. Find f prime. Now again, you might say, oh, I got division in here. This power rule can't work for this too. Oh, think again. Power rule definitely can work. I just have to put it in ax to the n form. Okay? So what I need to do is I need to move that x up into the numerator with the 8. But in order to do that, I have to follow my exponent rules. And think of this, instead of as 8 over x cubed, I want you to think of it as 8x to the negative 3. So again, I'm rewriting f of x. I'm going to hound you guys tomorrow on your notation and labeling things clearly. Did I do a derivative? No. All I did was rewrite f of x. So I still label it f of x equals. Once I go to do my derivative, then I'm going to label it f prime of x equals. Don't just write the answer as an expression. Write it as an equation. Okay? Now I'm in ax to the n form. So now I'm going to multiply. I'm going to take the power times the coefficient. But now I'm ready to do my derivative. So I'm going to write f prime of x equals. I'm going to multiply 8 to negative 3 and get negative 24. And then I have to subtract 1 from my power. Now please subtract correctly. I don't want to see a negative 2 here. Negative 3 minus 1 is most definitely negative 4. Negative 4. And again, if I had to evaluate f prime of 2, it's pretty hard to do in this form. So I like to change it back to a positive exponent. I'm going to write f prime of x equals negative 24 over x to the 4th. It's going to be super important that you can comfortably adjust these things to do a derivative and adjust it back at the end. All right, that's it for today. See you guys tomorrow. Talk to you later. Bye.